Hello, everyone. I am here to welcome you to another CBT Nuggets webinar. Topic of the day is Google Qualified Developer Certification BigQuery, and it's going to be run by the man of the hour, Garth Schulte. My name is Jeff Jones. I'm a training advisor here at CBT Nuggets. Everyone that wants to, you can revisit this on our blog, blog.cbtnuggets.com. And if you have questions throughout the webinar, please submit them in the chat pod. And without further ado, I want to hand it over to Mr. Garth Schulte.
Hey guys, thanks for taking the time out of your busy days to come learn about Google's Qualified Developer Certification and BigQuery. So we're going to talk a little bit about really two things. Obviously the certification, and then we want to really hone in on BigQuery because it is such an exciting piece of the Google Cloud Platform. So just to give you a little overview of what we're going to do here, we're going to start with a welcome. So welcome once again. We'll jump right into it and talk about Google first, because Google has been at this big data thing for a very long time. So we'll talk about their underlying technology, their infrastructure, how they handled and solved the big data challenges. And then we'll talk about the Google Cloud Platform, because that's really our way of accessing all of these homegrown systems that Google has built over the years to manage their big data. And then we'll hone in on BigQuery a little bit, talk about why they created BigQuery for themselves, and then why they opened it up to the public so we could access it. And then we'll get into BigQuery itself. We'll talk about the fundamentals, just go over what it is, what it isn't, why we should use it, give you a quick run through of all the components, and also just briefly show you how to get started, because it's really easy to get started. You'll be surprised at how quickly you can get up and running and start writing queries. It's pretty impressive. And I'll talk a little bit about pricing as well. And I'll show you the many ways that we can access BigQuery. We've got really 4 core ways that we can hit it, all the ways you would ever need to hit it. We'll go over a BigQuery pipeline, which is a reference architecture that Google put together, just to show you the many ways that you can ingest, go through the transformation process, get it into BigQuery, and then start writing queries and building visualizations on top of it. And we'll save the best piece for last here and talk about the certification. And all the certifications, because there's actually 5, 1 per Google Cloud Platform product. So we'll talk about that, and I'll just give you a rundown of what the kind of what the requirements are, what the process is, and what to expect if you were going to go get certified. All right, so let's get started. So Google is really known for handling data across data centers, right, across many machines. And it's really interesting because back when they started out, they solved the big data problem rather than scaling up with big machines. So that's how everybody did it back then, right? They just pumped lots of money into big machines. They said, hey, why not fill our data centers up with lots of cheap machines and then write our own homegrown software to distribute that data and then process it in parallel across all those machines. So they solved it in a really interesting way. And that's what all these underlying technologies here in Google's infrastructure, all these technologies run in all of their data centers across the globe. So they've got a network that spans the globe, data centers all over the place. And their Big Data 1.0 stack was really MapReduce in the Google file system along with Bigtable. And it was really focused on batch processing, right? You have Google file system, which is your data center-wide file system. Bigtable is their NoSQL database on top of that. And then MapReduce is their batch processing framework. So this is really Google Big Data Stack 1.0. And it was used for a very long time. And after 5 or 6 years of that software maturing, they kind of realized the challenges. And so they started with Big Data Stack 2.0, which added Dremel, Colossus. And then these are really just iterations of Bigtable. So Bigtable is their NoSQL store. Megastore adds transactions and sort of data center-wide consistency, and Expander adds global consistency. So really the moral of the story here is that Google built their own homegrown systems to handle big data by spreading it across armies of machines across data centers across the globe. And then comes the Google Cloud Platform, which is the way that we can access all of these underlying technologies, a nice public interface on top of it all. So you have something like App Engine, which is platform as a service, right? Virtualizing your software infrastructure. You have Compute Engine, which is infrastructure as a service, virtualizing your bare metal. You have Cloud SQL, which is database as a service. And pardon my pen here, it's a little weird. But database as a service, we can host our databases in the cloud. Cloud storage is really storage as a service, all that unstructured data. I like to think of it as the file system for the Google Cloud Platform. Cloud SQL is NoSQL as a service. And BigQuery is really analysis as a service. That's where it fits in this picture. And the interesting thing is is that all these technologies over here, you can kind of see underneath how these utilize it. So compute engine, for instance, is your block storage. Cloud SQL is your relational storage. Cloud storage is your blob storage. Cloud data storage is obviously our NoSQL storage, and then BigQuery is known as NewSQL, which is really the best of both worlds. It gives us the ease of use like we're used to in the relational world of SQL with the power and scalability of NoSQL. So that's kind of just a brief history of Google and why they built the Google Cloud Platform, right? To give us access to these incredible mature underlying technologies. Now, let's focus on BigQuery here, because BigQuery is really one of the interesting new things to come out of the cloud platform that everybody's excited about because it's in the world of big data. So in these data centers that are spread across the world here, Google had a problem. Back when the Google Data Stack 1.0, this is all batch processing. So if they wanted to, in real time, do things like diagnose hardware problems or monitor the health of their systems right now, they had to write MapReduce jobs and wait hours for those jobs to finish. So they could never really get real-time answers from their infrastructure. So that's where Dremel came from, which is what BigQuery is based on, and allowed them to write SQL queries on top of their data center. So now any Google engineer that's familiar with SQL can just whip off a SQL query and get an answer in real time. And so they are on top of their infrastructure. They know exactly when something goes down or something needs fixed. So that's it. That's how they find slow-running servers from billions of log entries across their data center, right in SQL. How cool is that? So that's what BigQuery is all about, giving the world a much easier way to access big data. So if we have to define what exactly BigQuery was, we call it an ad hoc data analysis tool for large data sets, and it's real-time SQL insights against our big data. And the real big thing here is we get to use Google's power to host and query that big data. What it isn't, it's not OLTP. It's not a transaction-based system. It's not what we're used to. If you're from the world of SQL, you're used to transactional systems. It's not that at all. It's an append-only system. So you can do inserts, but you can't do updates. It's closest to OLAP, even though it's not. It's definitely closest to it. Data warehousing and data marts and multi-dimensional data. The problem with OLAP is it's difficult to use. It's difficult to get your answers out because you have to write NDX queries and things of that nature. And BigQuery is different under the hood because its performance comes from its parallel processing architecture. So queries are processed, by thousands of servers in a multi-level execution tree structure, and BigQuery stores the data in a columnar format rather than record-based formats, which is what data warehousing, OLTP and OLAP use. So it only reads exactly what it needs. It doesn't have to read the entire record. It's not relational. It's not non-relational. So it's not SQL. It's not NoSQL. It's really the best of both worlds. And it's not MapReduce. MapReduce is really for batch processing. And if anybody's familiar with Hadoop, it's really what Hive wants to be. Because Hive, sure, it gives us SQL queries on top of our big data, on top of your Hadoop infrastructure, but really Hive is just a driver for MapReduce. It just spins up MapReduce jobs under the hood, and it takes just as long to execute as a MapReduce job. So that's really what BigQuery is. It's SQL-like queries, real-time answers on top of our big data. Why use it? Well, just because of that, because it's SQL queries. Auto-optimization, there's no indexes to worry about, which is huge. If you're from the SQL world, you're used to creating and managing indexes and trying to write queries to target those indexes. You don't have to worry about any of that. It's all handled under the hood. This one's kind of mind-boggling. No size limitations. It really isn't. You can put petabytes of data in BigQuery. And my favorite, it's just so easy to work with. Once you work with BigQuery, you will be blown away by how easy it is to get up and running, get your data into it, start querying, and then you can use third-party tools to create visualizations. You can write your own on top of the RESTful API. It's really, really easy to work with. And on top of that, it's easy to build against because the structure is super simple. You create a project, and this is a Google Cloud Platform project, which just contains things like users, your APIs, authentication, and billing. When you're in BigQuery, you start by creating a data set, which is just a container for your tables. Create a table which contains a schema that describes the kind of data, standard SQL stuff there, right? We're all used to creating tables and columns and defining the type of data that can go in them. Same exact thing here with BigQuery. Now, as far as getting started goes, like I mentioned, it's super easy. If you have a Google account, you just sign in with your Google account. If you don't have a Google account, go to accounts.google.com and create one. Then you can head over to cloud.google.com and create a GCP project, which we just looked at up there. And then once you have a project going, you can start writing queries. Obviously, if you want to work on your own data, you'll need to create a data set, load some data inside of the table, and go from there. But they have sample data sets that are really easy to work with. So if you just wanted to get in and start writing queries to see how it works, you can get up and running in under 5 minutes. Another important aspect here that everybody always questions me on here is pricing. How much is it? Well, if it's so cool and it's so easy to use and it sits in Google, it's got to be expensive, right? Well, no, it's not. It's actually very cheap. You only get charged for a couple of things here. Storage, which is 2.5 cents per gigabyte. That's pretty reasonable. And then you get charged for query. So how much data is actually getting processed when you write a query. And Google's got a lot of best practices out there, and I can even give you some at the end here that will really cut your costs down. But $5 per terabyte is also pretty reasonable, especially if you use those best practices and you shard your data, by month or year or whatever, then you can really cut down the amount of data that's processed. And then all your DevOps type stuff, so reading, copying, exporting, and some other things, all the stuff you do in the web UI for management, it's all free. So it's a great tool, a great cloud analysis as a service tool that's super cheap. Now to access it, we've got a couple of ways. Obviously here we have the BigQuery web UI at cloud.google.com. It's actually at bigquery.cloud.google.com that you can head into. You'll get this nice interface. It's very simple. There's not a lot you can do but create data sets, create tables, and then you have this interactive console that you can use for querying. So you can quickly, it's a great development tool, quickly write little queries to shape exactly what you want to get out of your data. Let's see, we've got over here, we've got the BigQuery command line interface. You can hit BigQuery from the command line. Great for managing stuff, great for loading up your data, great for scripting out that whole process. We've got a RESTful API, which is also incredibly easy to use because Google supplies client libraries across virtually any language. So if you're coming from the world of Java, Python, .NET, Objective-C, Ruby, the list goes on and on. They've got client libraries below that make it really easy. They all sit on top of the API. If you're a programmer, you know how client libraries go. They're super easy to work with. And then there's also an array of third-party tools out there. These are growing every day. You've got everything from visualization tools to ETL tools, and there's even direct ODBC connectors that you can use from your ETL system to get your data up into BigQuery. So it's super easy to work with and to access. Now I love this pipeline. I'm always talking, every BigQuery, anything I do, I involve this reference architecture from Google because it's a great big picture, but it also just shows how, not only how the whole process works, but how easy it is to work with the Google Cloud Platform, many of these products. So there's really 4 phases, we'll call them, inside of a big data pipeline. Right? You have your ingestion phase, and this is going to usually involve getting that data out of your source system and into a format that BigQuery can understand. So this could come from your relational database, your CRM database. It could come from log files. And just a little side note here, how many sysadmins are out there when you have a problem with your web servers or your any server, you're scouring the logs to look for those problems. Wouldn't it be nice if you could take all that data, type it up into BigQuery, slap a dashboard on it, and in real time have that data tell you where and what the problem is. So you can identify everything from abuse to access, everything. It's a pretty cool tool. Also, Google Analytics, another fun fact here. Google Analytics, if you were to export your data using the web UI, you only get the rolled up data. BigQuery, if you access it through BigQuery, you actually get the raw data. It's the only way to get the raw data right now through Google Analytics. So if you're a big analytics user, you can start getting access to the raw data, writing your own custom reports, and doing some pretty cool stuff with it. Back to the slide here. So once you get your ETL process set up, and you get that data wherever it sits out of there, the general next step is to get it into Google Cloud Storage. At this point, you're on Google's network. Everything's going to be super fast. And a benefit of doing this, going from ETL right to Google Cloud Storage, is Cloud Storage supports resumable uploads. So if something were to happen, if you're uploading terabytes or petabytes of data, and something happens, you can just restart it from where it left off. You can also just upload right from ETL using those connectors to BigQuery. So if you don't need to do any transforming or getting it into a format that BigQuery understands, like CSV or JSON, or aggregating or doing anything to your data, then you could absolutely just put it right into BigQuery. But one of the nice things here is once you get into Cloud Storage, now you have an array of tools in the Google Cloud Platform to work with that data. And App Engine is such a great tool because it's a great orchestrator. You can orchestrate the whole process. So you can create cron jobs, so at scheduled times you can pull your data off of Cloud Storage and push it over to BigQuery. Or you can use the object change notification feature in Cloud Storage that will actually hook right in to your App Engine app so you can process that data and send it over to BigQuery. Or you can spin up compute engine instances with Hadoop on it to do any further transformations, or you can use the API from from the MapReduce API from App Engine to do that same thing. You can also stream your data into BigQuery, or you can push it back to Google Cloud Storage and bulk load it. The advantage that streaming has is your data is available as soon as it hits BigQuery, where if you bulk load it, you have to wait for the whole process to finish before you can access your data. These are obviously optional components because, again, if you don't have the need to do any further transformations, and you can just go from retail tools to BigQuery or to Cloud Storage and then to BigQuery. Once it's in BigQuery, it's super easy to write applications that tap into visualization APIs or these third-party tools to get that data into a dashboard that users can work with. So that's it, really. Ingest, transform, load, query, and visualize. And I've got a really interesting slide here that I want to show you. I had the opportunity to head down to Google and take a class for all these products. And this was actually one of the slides that everybody's kind of jaw hit the floor, and along with their brain matter, and they had to pick it all up. And it was pretty funny to see the look on people's faces when this slide came up, because everybody's familiar. If you're familiar with Hadoop, you know all about the minute sort test, right? How fast can your cluster sort data, and how much data can it sort in a minute? Well, the previous record here is 1.4 terabytes. It took 2,200 servers. It cost $5,000 per server. But look at this. $10 million is what it came to, and it took months to set up that cluster and run the test. Doing this in the Google Cloud Platform with Google Compute Engine, process more data with less servers, and look at that cost, $20 as opposed to $10 million, and it took minutes rather than months. So that's kind of the power of the cloud in general, any cloud really, right? That's why everyone's moving to virtualization, because it's super cheap. But on top of that, we get the advantage of spinning up these clusters. So how MapR did this is they wrote a script that just spun up the clusters, brought up the Hadoop cluster, ran the MapReduce job, got the results, and then tore down the cluster. So that's how they cut their costs a little, because the whole cluster is only running for the time that it needed to run the MapReduce job. Pretty cool stuff right there. So the last thing I want to talk about here was the Google Qualified Developer Certification. So Google just recently started announcing these certs. Our NDA was just listed a few weeks ago here, so we could start talking about them. But it's neat that Google's coming out with certifications, because now the world can get certified on their cloud and show, hey, I know this stuff, I can do this stuff. And so they have a certification for each product in the cloud. Generally, they're going to be 90 minutes long, except for Cloud SQL, because there's not much to it. It's pretty straightforward. It's only 60 minutes long. And here's just a brief overview of all the topics here. In App Engine, it's really just getting familiar with developing an application in the cloud, deploying it, architecting, optimizing. It's really not that bad. There's not a lot to it because Google manages the infrastructure, so we can just focus on application development. So the main core of the App Engine test is understanding obviously how to build an application, but also the data store is a big thing. That's the NoSQL side of App Engine. That's super neat. Cloud Storage, another good one here. Just if you're familiar with AWS, then you're already familiar with Google Cloud Storage. Google just has their own little spin on it with their own, features inside of it, and really good App Engine integration. So that's a big part of the exam too. Cloud SQL, as I mentioned, there's not much to it. Just basically spinning up a database, administering it, interoperating from App Engine, and then some other things interoperating with other technologies or tools, external tools and such. BigQuery, really, it's a fun exam. I think it was one of the most interesting exams because the basics are one thing. Everybody's pretty familiar, if you're in the data world, with the basics of SQL and maybe to some extent NoSQL. But they actually get into the development side of it and hitting that API, pulling it, creating visualizations using third-party tools. And on the advanced side, they get into exactly how BigQuery processes. If you're familiar with MapReduce, mappers, and reducers, it's very similar, but it's a little bit different in how it's architected. And so that's really part of the BigQuery course, focused a lot on that. And our BigQuery course, we'll get into that as well. And then Compute Engine, very similar to EC2, again, just Google's spin on it. And it's more developer-focused, right? And that's the one thing with Google's Cloud is it's very developer-centric. They want you familiar with these APIs, because to do something like write that pipeline, you're going to spin up Hadoop clusters by hitting that API from App Engine, so you can orchestrate that whole process. Putting files in Cloud Storage, you need to hit the Cloud Storage API. Getting data out of BigQuery, you need to hit the BigQuery API. So again, with those client libraries, it makes it really, really easy to work with. Now, as far as what the requirements are here and how these exams work, they're web-based time exams you can take anywhere. That's right, you can take them from home. I did. I took them out from home. The only thing that's required is a camera because they're proctored. Somebody needs to watch you. Even though it's an open web exam, you can do anything you want. You can go to Google, type in questions, scour their documentation, whatever you need to do. They just want to make sure that you don't have somebody sitting next to you helping you out. So that's why a camera is enabled. So that's pretty cool that they're open web, and that really makes a big difference because some of the questions, when they ask you something that nobody's ever going to memorize, then it's nice to have the documentation there so you can take a look at frequently asked questions and things like pricing and resource consumption, all that stuff. What you're actually tested on, though, is the fundamentals of each project. Passing an exam will give you the Google Qualified Developer title for that exam. And just to show you here, here's what you'll get for passing. I passed all 5. I got a certificate for each one. Passing any 3 of them will then get you the Google Qualified Cloud Platform Developer title. So yeah, Google got into certifications. Pretty cool stuff. That's all I got. Wanted to thank you guys here for joining me. Follow me on Twitter or ask me questions anytime. I'm also on Facebook there. And I also want to mention to catch us here at IC3. This is a cloud conference in San Francisco in October. You get more details at ic3cloud.com. You can meet myself, Jeremy Chara, and Ben Finkel in person. We'll all be there. And presenting, Ben Finkel and I will be doing stuff in Google's cloud. Jeremy will be doing stuff in AWS. And it's bound to be a lot of fun, and we'll learn a lot. Questions?
Hey, Garth. Yeah, we got a couple questions here. First one.
All right.
Are there any best practices for managing large amounts of data in BigQuery?
Yeah, that's the one thing I really wanted to talk about because, as I mentioned, with BigQuery, you get charged for how much data is processed. So what you can do, rather than just load all terabytes of your data into one table, you can shard it by time. So say you make a table for every month. You can put all your data for that month in that table, and then just write queries against that table. Or I've seen people that do it all the way down to the weekly basis. And then it's so easy to join tables together or union your tables together. And BigQuery's got some really nice functions that allow you to actually write queries on top of your table. So in your from clause, you can put a filter that says, give me all the tables that are in this month. And it'll query all those tables in a month. It's a really powerful feature. So yeah, it's a great way to reduce cost and improve performance, obviously, because you're only hitting the data that you want.
All right. Hey, we got a couple more questions coming in here. How much is the price for individual exams?
Right now, it's $100.
Okay.
There's ways. I think there's ways that we can give vouchers and stuff to lower that if you go through certain areas. But right now, if you go right to Google's training site and sign up for an exam, it's $100.
Okay, perfect. And can a networking person opt for cloud technology?
Learn cloud technology? Yeah, anybody can get into this stuff. I'm not sure I understand the question there.
Okay. And we got one more here. Is MS integrating BigQuery into SQL Server 2014?
That's a great question. I don't think Microsoft is, but again, with this ETL stuff, I mean, you can hit it from anywhere. So if you're familiar with, say, SQL Server integration services, there are third-party connectors out there that you can hit right from integration services and bring your data, either pipe your data from SQL Server up to BigQuery, or if you need to bring your data from BigQuery into SQL Server, you can do that as well.
Okay. All right. How big can your data in BigQuery be?
That's as big as you want. I mean, terabytes is no problem. Petabytes, Google has said, petabytes aren't a problem as well. I haven't seen anybody get in the petabyte range, but I've certainly seen terabytes, and it can handle no problem. In fact, they actually have a sample data set up there that is 3 terabytes that you can hit, and it handles it with ease.
Okay, gotcha. And can I only access BigQuery data programmatically from App Engine?
No, you can access it from any language, really, using the REST API directly. Or, as I mentioned, there are lots of client libraries out there across many, many languages that make it super easy to tap into it. So the answer to that is no, you can hit it from anywhere.
Okay, perfect. And we got one more here. Let's say I have data in Data Store. How can I get it into BigQuery?
Another good one. There's an interesting new experimental feature out there that Google put out recently that allows you to take a backup of your data store and ingest it directly into BigQuery. And it also automatically takes care of the schema for you. So very easy to do.
All right. We got another one coming in here. What are the major companies that are implementing BigQuery at this time? Do you know?
Another good question. Yeah, Google actually has a case study page that shows lots of companies that are doing it, but there's a lot of them out there. I mean, it really depends on what you're doing, but once companies start realizing that, especially ones that already have a Hadoop cluster up there, once they start realizing how much money they can save by taking the end of their pipeline and moving into BigQuery, you're going to see a lot more people jump on this technology. And to that, right now, writing things like MapReduce jobs are very difficult to do, and you can't get your answers in real time. So again, once this technology really starts to get out there, I think you're going to see the adoption rate just go through the roof.
Sure. All right. Well, Garth, I think we're time to wrap up unless you got any closing statements here. I want to thank everyone for attending this webinar. I want to thank you, Mr. Garth Schulte, for hosting. And I want to remind you guys that we have a recording of this webinar on blog.cbtnuggets.com. And if you have any other questions that we didn't get to, make sure to send them to Garth's Twitter handle @GarthSchulte. Do you have any other comments, Garth?
No, please do. I'm always open for questions, suggestions. I'll get right back to you. I love questions. I love interacting with everyone. So please send them my way. And thank you.
All right, will do. Thank you, Garth.
Thanks, guys.